Hello, welcome. Yes, so we are gonna do today, our next section on, computational strings. So the kind of big project for this section is, computational poetry. So you're gonna end up being able to write, Mad Libs haikus, which is pretty cool. And in order to get there, we need to talk about string manipulation, patterns and select, and list manipulation in order to be able to get the computer to write some poetry for us. Yep, so just like yesterday, we're going to watch a video, we're going to take a quiz, I'm going to go through one or two of the exercises from the exercise notebooks, and we'll keep doing that until we're done. Okay, so let's watch our string manipulation video. Hello, so this is the start of our section on computational strings, and our goal for this section is to be able to write some poetry using Wolfram Language. So first out, we're going to start off by learning about string manipulation. So in this section, we're going to be working with strings to write and analyze text. By the end of this session, you're going to be able to compare and contrast strings with other data types, so learning the different data type that is a string. We're going to be able to write code to manipulate strings, and we're going to be able to generate strings using templates, which are a really cool way of working with strings in Wolfram Language. So there are loads of different ways to get words in the Wolfram Language. The basic way, easiest way, is that we can look at the dictionary, which gives us a list of about 40,000 words in English. So if we look at word list, then we get this really long list of words, which we can do all kinds of stuff with. We can also use functions like random word to generate a random word. And within random word, we can specify if we want a noun, verb, adjective, or a different type of word. So let's get a tiny bit more complicated. So we're going to be joining and splitting strings. So all text in Wolfram Language is a string. So if we look at the head of the string hello, it's going to tell us that it's a string. We write strings using quotation marks. So quotation marks, the string, end quotation marks, gives us a string. If we have multiple words in a string, then we can separate them using a function called string split, which automatically splits the string at each space. So if we type in our string with multiple words, then we're going to get out our nice list of separate strings. If we want to join a list of strings together into one string, then we can do that with string join. So if I give it my list of strings, then it will return a single string with all those words slammed together. So that looks a little weird because we lost all of the spaces. A way we can get those back and also do all kinds of other things is by using a function called riffle, which puts something in between every item in a list. So I'm going to give riffle my list of strings, and I'm going to tell it to put a string that is just a single space in between all of the strings. And now I get my list, including a bunch of strings that are just a space. And then if I string join those back together, then I get my sentence back with all of its spaces in the right place. And obviously we don't have to do this using two different lines of code. We can nest our functions. So if we string join the riffle of this, then we get our nice sentence back. Great, so now let's move into manipulating our strings. There are a bunch of functions that we can use to analyze and manipulate strings. A number of them are similar to functions that we've already seen on other data types like lists, but these versions of the functions work on strings. So for example, string part works just like part. So we give it our string and we say we'd like the 10th part of this. In this case, we get our t, which is the 10th item in our string. Similarly, string length will give us the length of the string. String drop allows us to drop everything from the beginning. So if we say we'd like 10 things, then we get to drop everything except for the last 10. Same thing works with take. So string take. String reverse lets us reverse all the letters in the string. String join is a function we've already used. and it's really useful when working with deconstructing and reconstructing strings. So we can use the full form of string join, which we've looked at already, or we can use our two greater than, less than signs as shorthand, so we can just plop them all in. Most string functions are listable, which means that we can apply them to all items in a list without needing to use map or table. For example, we can find all the words in this string and then find the length of all of the words. So text words gives us a list of all of the words, and then if we do string length to that list of all the words, it's going to tell us the length of each of those individual strings. Fantastic. So the final thing we're going to learn is about using templates. So a really cool thing that we can do with strings is inserting a piece of text into another piece of text using template and the rule function. So if I write out the string template of my name is, and then I do these backward ticks around name, then I can set up an association next to it that says whenever you see backward tick name, replace it with Harry Potter. So now I get my name is Harry Potter. We can do this multiple times just by adding things to the association. So I make sure that I label the things that I want to replace with the keys from the association. I write out the association, and now I can replace the text. We can even evaluate code before we put it into the string using rule delayed. So if I make up a string template and I want to just have a random number put in there, then I can do, my favorite number is backtick number, and then I can replace number with a random integer between 1 and 100, and each time I evaluate this now, I'm going to get a different number that's my favorite number. So templates are going to be really important as we move through the next few lessons and into the next project, and they can be really helpful with doing all kinds of things like writing reports, making websites, and all kinds of activities and adventures that you might get up to later. So in summary, for this lesson, we've covered a lot of basic string manipulation, and our key takeaways from the lesson are that we represent text in Wolfram using strings, and we indicate those strings with quotation marks. There are loads of functions that we can use to manipulate a string. Some of them have names that are really similar to functions that work with other type of data, but in this case it only works for strings. And string template is a really cool function that lets us computationally build up a piece of text by replacing a section of the string. Great, then we will see you in our next lesson. Thank you. Awesome. So let's do a quick couple of polls. So let's start off with this one. So what is the difference between join and string join? So the correct answer for this is that join combines okay, so the important thing to note here is that string join joins multiple strings into one string, whereas join will not really work in the same way on strings. So for example, let's just look right here. Let me share this screen. So for example, if I did join hello world, it doesn't want to do that. Whereas if I do string join of these two, then it joins them together. So that's the important thing to note. So A was the correct response. So congratulations on that one. Let's see. Yeah, let's try this one as well. So which use of string template will return the string an example of a string template? Okay, fantastic. So almost everybody got that, and this is correct. String template, example of backticks function, and then an association with function goes to string template, will give us an example of string template. Congratulations. Okay, so let's have a look at one of these exercises. So we're gonna try exercise 2. So find the letter halfway through the Arabic alphabet using string manipulation. So how do we get the alphabet? We type alphabet. That's in English. So let's specifically get the Arabic alphabet. Boom. Got a nice little Arabic alphabet here. Now we want the one that's halfway through. So that's going to be, if we math at ourselves, we want the length of this alphabet, and we want the 28 divided by 2 letter in this place. So we're going to use the function string. Sorry, 1 second. Let me just remember exactly what function we're using. Yeah, we're using the function string part to find the 28 divided by 2 part. But I didn't do that properly. Sorry. I'm sorry. I screwed that up for you. So we've got the alphabet. We need to string join it, which I didn't do. String join this guy right there. And then we'll, I'm sorry. We've got the string join of the alphabet. We want the string length of the alphabet. And then we'll take the string part of that alphabet, and we'll take the 28 divided by second part of that alphabet. Let's do another one, seeing as I screwed that one up for you so nicely. So if we make a string template for the following sentence to replace the name and the color. So in that case, we're going to want our string template, and we're going to want our sentence right here. Boom. But instead of this guy, we're going to want backtick name, and we're going to want backtick of color right there. And then we just need to set up our little association, which will give us, we're going to want name, and I'm going to put Rory right there. And we're going to want to define color. And my favorite color is red. So we're going to put that right there. My name is Rory. My favorite color is red. So fantastic. Let's have a look at the next video where we're going to be talking about patterns and select. This is pretty important and has a lot of Wolfram language skills that we're going to learn right here. So,
hello. So in this lesson, we're going to be talking through patterns and select. The learning objectives are to identify when an input does or doesn't match a pattern, choose between blank blank sequence and blank null sequence, which are functions we're going to cover when constructing a pattern, composing string patterns, so building patterns for strings, recognizing built-in functions that are going to return true or false, and constructing tests that can be used in functions like select. So starting off with patterns, we can use patterns to look for and test things in Wolfram language. The most basic pattern that we're going to be talking about is blank, which can also be written with a single underscore. So blank just means this is one thing, and it can be anything. A standard function to test a pattern is matchQ. MatchQ asks if one thing matches another thing. So if I do matchQ of 2 strings that both say the same thing, then we get true. If I do matchQ of 2 strings that have different content, we're going to get false. We can replace the second item with a blank to test if the first item is one thing that can be anything. So if I do a string of the word hi, comma blank, and ask if it matches, I'm going to get true, because a string of the comma blank is one thing that can be anything. And this allows us to build out much more complicated patterns. So for example, we might want to find a list that has the string hi in the second position and has exactly 3 things in it, but we don't care what the first thing is or what the third thing is. So in that case,
I would say, does this list, blah, high, and 17, match the pattern? A thing that can be anything. High, a string of the word high. Another thing that can be anything. Yes, it does. Great. Now let's get a tiny bit more complicated. So blank sequence and blank null sequence are two other functions. Where blank means a single thing that can be anything, blank sequence, which can be written with a double underscore, means a sequence of one or more things that can be anything. So if we wanted to test that high is somewhere in the list, with at least one thing before it, at least one thing after it, but we don't care how many things are before and after it, we use blank sequence instead of blank. So if I ask matchQ to take a list of things with high in the list, and I say, does this match the pattern? One or more things that can be anything. String that says high. One or more things that can be anything. True. Yes, it can. If we don't care if there's anything at all before or after high, we could use blank null sequence, which will return true if there is a sequence of 0 or more things. So in this case, high is at the front of the list in the first position, so there's nothing in front of it. And I want to test if this list matches the pattern. List of 0 or more things, high. List of 1 or more things, true. So let's get more specific with string patterns. So many functions that work to test anything also work to test on strings. But if we want to test a substring, then we need to use functions that specifically work on strings. So for example, blank works with strings similarly to how it would work with a list of items. So if I have a list with just one thing in it, and I say, does this match a list of one thing? That's true. If I have a list with nothing in it, and I say, does this match a list of one thing? That's false, because the list doesn't contain anything. But if we want to test inside the string, we need to use string matchQ. So matchQ will test if there is a string present. String matchQ will test if there's anything inside the string. So matchQ, string with a space, blank is true. MatchQ of nothing at all is also true. But if I want to test inside the string to see if there's anything inside the string, I would need to use string matchQ. So string matchQ of a space, is that something? That's true. String matchQ of nothing at all, is that something? No, it is not. If we want to use specifications within our string pattern, we can use double tilde, these two wavy lines, to indicate a string join within the pattern. So a string match of string fun, does this match f joined with a sequence of one or more things? Yes. String match of fun, does this match with f joined with a sequence of one or more things joined with b? No, it doesn't. There's no b in fun. We also have access to other matching functions like string starts q, string ends q, string contains q, or string cases. String cases is going to extract instances of a certain phrase or string. So if I ask for all of the cases within test where there is t joined with one thing, it's going to give me te, because that's the only instance in this string where there's t followed by one thing. One interesting thing that we can do with patterns is return only the part of the pattern that we're looking for. So let's say that we want to find the words in this string that are within quotation marks. We can look for the shortest match to a string pattern beginning and ending with quotation marks. So I say string cases within those sentences that are the shortest between a quotation mark and string joined with a sequence of one or more things joined with another speech mark. And that's going to return exciting sentence and exciting things. Fantastic. So if we want to only return the part within the quotation marks, without the quotation marks included, then we can use the variable within our pattern for the part that we'd like to return. So I would do in exactly the same way with the string cases sentences shortest, and then I want between the two quotation marks. But instead of just using a blank sequence, I'm going to call that blank sequence x. And then I'm going to use a rule to get only x instead of x and all of the other stuff that we put within the function shortest. So that's going to give us exciting sentence and exciting things without our quote marks. So that's pretty great. We've looked at a lot of different examples of ways to select within strings and see text that matches patterns. Now we're going to look at selecting items in a list based on a criteria. So we might want to select a certain thing based on a criterion. So there are a bunch of criteria that we might want to select for. Maybe we want to find strings that are exactly 5 characters long, or strings that start with an A, or strings that are palindromes, so the word is the same forward as it is backwards. So let's figure out how we would check to see if a string is 5 characters long. We'd want to use the function string length to see how long a string is. So string length of hello is 5. We can test if something is true using operators. Some of the most common operators are double equals to see if two things are the same, larger than to test if the first thing is bigger than the second thing, smaller than to see if the second thing is bigger than the first thing. So if I say, is string length of hello equal to 5, it returns true. Finding palindromes is also really easy with operators. We just test to see if the string is the same as the string in reverse. So if I do race car, is it equal to string reverse of race car, I'm going to get true. We can do lots of other things using any function that returns either true or false. So for example, we could check to see if a number is even using even q. So even q of 5 is false, even q of 8 is true. Functions with a q will only ever return true or false, and this is really helpful for functions like select, which we're going to discuss next. However, there are other functions that will return true or false that don't end in a q. For example, the function divisible checks to see if a number is divisible by another number. So divisible 10 by 2 is 10 divisible by 2 is true. So now let's talk about select. The function select allows us to use one of these tests to find all the items in the list that meet a criterion. Select takes a list as its first argument, and its second argument is a function that will return true or false when given one value from that list. Select is then going to apply that function to each item in the list and only return the values where the function evaluates to true. Just a second ago, we used even q to return true if a number is even and false if a number is odd. If we want to select all of the even numbers in a list, we would do select of our list of numbers and give select the criteria even q, and then it's going to return all of the things that when it evaluated even q for that number, it returned true. Even q is nice and simple because the function returns true or false. If we want to use an operator, then we need to get just a little sneaky and use a pure anonymous function. So remember that the slot, the hashtag, just means the one you're looking at right now. So select looks at the first item, then the second item, etc. And the ampersand, the and sign, just tells Wolfram Language that everything before the ampersand should be considered to be part of the function. So let's find all the strings in a list that have a length of 5. Select is going to look at each item in the list and run the test on it. And in this case, it's going to test if the output of string length is equal to 5. If the test is true, select is going to give us the item. If it's false, then it won't give us anything for that item. So if I put through select my list of words and I say string length of slot of the thing that we're looking at right now, does it equal 5? And then I close it off with an ampersand, then it's going to give me the list of all the words in this list that are length 5. Now, if you're questioning there, well, it says Harry twice in this list. Well, it doesn't. Harry is a single string in the list, just as its own thing, which has a length of 5. And Harry is also within a longer string, which doesn't have a length of 5. So string length, as we know, is going to take the length of the whole string, not the length of all of the words within the string. We could do that using text words or by splitting all of the strings into their composite words using string split. But in this case, we just wanted the strings that are length 5, not any substrings that are length 5. So that's what select gave us. Fantastic. So in this lesson, we've covered patterns and the function select. And our key takeaways from this lesson are going to be that Patterns let us compare an input to a partially defined sequence, and we can use pattern inside match Q. Patterns can use blank, single underscore, blank sequence, a double underscore, and blank null sequence. Blank is any single thing, blank sequence is a sequence of one or more things, and blank null sequence is a sequence of 0 or more things. Similarly to string manipulation, strings have their own set of pattern matching functions like string match Q, and these look for patterns within the string. We can construct tests or expressions that will return true or false, and these can be used inside other functions to only complete a task if the test returns true. Select is one case for tests, and select will only return the elements of a list when the result of the test is true. So we've learned a lot in this lesson, and I'm looking forward to seeing you next time. Thank you.
Fantastic. There was a lot in that. So let's do a couple of polls. So which of the following pieces of code is going to give us false? We've got a little bit of debate going on here. So let's just have a look at a couple of these. So if we have string match Wolfram, and then we want to test is the first thing W, and then the next thing is one or more things, then this is going to be true, right? So it's Wolfram, the first thing is W, and then after that, there's one or more things. We can see that is true. If we look at this guy, string match Q, it's Wolfram, it starts with a W, and then there's one or more things, and then the last thing is an M. That's also going to be true, because that's how we spell Wolfram. If we look at that final answer, match Q of some numbers, and then high, and then some more numbers, we're testing if this is one or more things that can be anything, and then high, and then one or more things that can be anything. So this is one or more things that can be anything. This is high. Then this is one or more things that can be anything. So that's also going to be true. And then the last one, so we were looking for false. So match Q of numbers, high numbers, is this a single thing that can be anything, followed by high, followed by a single thing that can be anything. And that is going to be false, because this is more than one thing. This is more than one thing. Yeah, so hopefully that makes sense, that this was going to be false. Great. So congratulations to those of you who got that one down. So let's do a couple of exercises. So let's start out with finding all of the sublists that end in B in this list. So let's just have a look at what these lists are made up of. So we can see this one that ends in a B has one thing just before it. This one doesn't end in a B. This one that ends in a B is only a B. This one ends in a B, has two things before it. This one doesn't end in a B. This one ends in a B, but it has a different data type. So in order to get all of the lists that end in B in this section, we're going to have to be pretty general. So we're going to want to capture anything that doesn't have anything before the B, capture anything that does have something before the B, capture something that has 2 or 3 or 15 or whatever things before the B, and we want to make sure that we don't care if it's a string or an expression or a number, whatever. So we're going to use function cases, and we're going to take our little list. So we want all the cases where it matches a pattern, and the pattern, I think we're going to do 3 underscores for anything or nothing, a list of 0 or more things before the B, and then we're going to want to finish off with a B. So Fantastic. So we've managed to isolate the ones that we identified with our eyes as ending in a B. So that's pretty helpful. Let's also do let's do this one. So we want all of the words that are in capital letters in this string. So we've got this exciting, many exciting things to say. So the first thing that we're going to need to do is split this string into words. We could do that with string split to split based on where the spaces are, or we can use the function text words. And then if I just copy this guy, then now I have my list of all of the strings, all of the words as individual strings. And then I'm going to want to select based on if they are uppercase or lowercase. So luckily, we have a function called uppercase Q, which will return true or false, which is what select needs, based on if something is in uppercase. So all I got to do for this is select the ones that meet the pattern uppercase Q. So what select will do is it'll look at this one and it'll say, is this uppercase? True. Then I'll return it. Look at this one. Is this uppercase? No. So I'm not going to return it. So now we get our nice little list of all of the words that are in capital letters. Fantastic. So hopefully that was clear enough. Okay, so yeah, so let's follow our next video on list manipulation. We're going to learn how to do that.
So in this final section on computational strings, we're going to learn the last skill that we're going to need for our poetry mini project, which is list manipulation. So at the end of this lesson, you should be able to select parts of a list or a nested list, and you should be able to construct and organize a list or multiple lists. So let's start out with making lists. We've seen a lot of ways to make lists so far. We can just write one out, and as we know, lists can contain any number of things of any type, and they start and end with a curly brace. Many functions have lists as their output, like range, random color, and alphabet. Some other interesting functions with lists as their outputs are things like integer digits and characters, which break up a number or a string. So if I do integer digits of 1998, then I get the list of integers within that number. If I do characters within the string Wolfram, then I get a list of the characters within that string. And of course, we can generate lists using table. So if I do table of anything, and I can ask table to do anything to my variable, and then I ask it to do it, for example, within a range, then it's going to return me a nice list. Now let's talk about getting elements of a list. So if we want to get a specific item in a list, there are several different ways that we can do that, depending on exactly what we want. If we're specifically looking for the first or the last element in the list, then we can use the function first or the function last. The most general function for getting elements of a list is part, which returns the element at a specific position. So we can say part of a list, the second one, please. It'll give us the second part of that list. Part is more commonly written with the shorthand double square braces, so because it's quicker. So if I give it a list and I say I would like the second part of that list, it'll give me the second part of that list. We can also use part to get multiple elements of the list. So for example, we can use double semicolon, which means span. So I can get parts of the list 2 spanning to 5, so numbers 2, 3, 4, and 5, and that returns the second, third, fourth, and fifth item in the list. We can use the function take to do the exact same task. So take returns the first n elements in the list. So if I do take the first 2, then I get the first 2 items in the list. Or we can ask it to take the last n elements in the list, just using minus. So if I do take -2, I'm going to get the last 2 elements in the list. Similarly, I can get elements n through m in a list. So if I take the 2nd to the 5th items in the list, I'll get the 2nd through the 5th items in the list. So drop, on the other hand, returns the list with the first n elements dropped. So everything other than the first n elements. So in this case, if I said drop the first 4 elements, it gives me the final 2. Or it can do the last n elements dropped with the minus sign, just like for take. So if I ask it to return the list with the final 4 elements dropped, then it returns the first 2 elements. Drop can also remove an element at a specific position. So if I put it in curly braces, I say I'd like you to remove the 4th element from the list, then it removes the 4th element of the list. Some other ways to manipulate lists are things like min and max, which return the smallest and the largest element in the list. So all of that was helpful for single lists, but we can also have lists of lists. We might get a list of lists by writing out coordinates, and if we want to get the second coordinate, the second list in the lists of lists, then we use part just like normal. So the second element of this list is the list 2, 2. If we want to get the first x value of the second coordinate, then we would use part twice. So I want the second element of the list, which is 2, 2, and I want the first element of that, which is 2. And if we want the first element of each list, then we can use part along with the function all. So if I say I would like all of the first parts, then I get all of the first parts, 0, 2, and 2. So let's move on to sorting a list. So the most obvious function for sorting a list is sort, which returns the sorted version of the list. Sort is also going to put strings in alphabetical order, and we can use reverse sort to get the sorted order from largest to smallest. So we don't have to sort it and then reverse it. Another thing that we might want to do with a list is counting. So we might want to find out how many elements are in a list, which we've done lots of times before, and we could do that using length. We might also want to find out how many times a particular element appears in the list. So the function count takes a list, and it takes the thing that you're looking for, the thing that you would like to count, and in this case it's going to count how many red squares are in my list, which in this case is 9. Or we might want to know how many times every element appears in the list. In this case I could use the function tally, which is going to tell me that I have 9 reds, 12 blues, and 4 yellows. So those are some really helpful counting functions. Beyond sorting lists, we might need to split lists up or merge multiple lists together. So let's have a look at rearranging lists. The first thing that we might want to do is merging. One of the most useful functions for working with lists is flatten. Flatten flattens out nested lists into one big list. So if I give it a list of 2 lists, it gives me back one list. Join does a very similar thing by taking multiple lists and joining them into a single list. There are various reasons why you would use flatten or join in different ways. Riffle takes 2 lists and intersperses them so that you get the first element from the first list and then the first element from the second list and so on. So you get to intersperse those lists. And as we've seen before, we can use riffle to put a single element in between all the items in a list. So in this case I wanted to put black in between all of the items in the list, and now every other item in the list is black. Now let's work on splitting lists into different smaller lists. So one of the easiest functions we can use is partition, which breaks a list into smaller lists with a specific length. So if I have my list here and I say I'd like you to partition it into lists of length 2, then we can get 3 lists of length 2. If we have a list with lots of repeating elements, then we can use split to split the list into smaller lists containing runs of the same element. So in this case, I have runs of the same element, and so I'd like to split the list into all of the first element, then all of the second element, then all of the third element. And I can do that using split. If our repeating elements aren't in order, then we can use gather to sort and split at the same time. So now I have this crazy list that has colors in lots of different spots. I would like to gather them gather like ones together and split them into different lists, and I can do that using the function gather. So what if I wanted to delete all the duplicates in a list? So we could do something complicated like using gather to gather all of my series together, and then I would have a list of reds, a list of blues, and a list of yellows, and then I could just get the first item in each of those lists. So now I have a red, a blue, and a yellow, and all of my duplicates have been deleted. Or we could make it nice and easy for ourselves, and we can use the delete duplicates function. So the delete duplicates function just deletes all of the duplicates. And now I have my list of red, blue, and yellow. So in this lesson, we've covered some basic list manipulation, and our key takeaways from this lesson are that lists are a collection of things. There are lots of different ways to generate lists and functions that output lists. We can get one element or a section of elements with part, and other related functions include first, last, take, and drop, and we can use part on nested lists. We can rearrange items in multiple different ways. In this lesson, we learned how to organize a list with sort, count elements in a list with count or tally, combine lists with flatten, join, or riffle, split a list with partition, split, and gather, remove duplicates with gather, and delete duplicates. So again, we've learned a huge amount today, and you should now be ready to do the mini project for this section, so I hope that you have a great time writing some computational poetry.
Fantastic. So let's do a couple of polls. So which function does not combine lists together? Which function can you not use to combine lists? Okay, awesome. So join definitely does combine lists together. You can put two lists into join and it will join them together to make one list. Riffle you can use to do the same thing, except that instead of putting your 1, 2, 3, 4, 5, 6 into 1, 1, 2, 3, 4, 5, 6, you would get 1, 4, 2, 5, 3, 6. Flatten also definitely combines lists. It just gets rid of your nested lists and makes it into one list. So the one that does not combine lists is gather. Gather will actually split your lists into multiple different lists depending on the type of variable that you have. Great, well done. And then our last poll question for the day. What is the shorthand for part? /@ double square brackets, double curve brackets, or double @ What shorthand do we use for part? Okay, fantastic. Yes, the shorthand for part is double square brackets. Well done. Okay, so let's do just a couple of exercises. And to this one. Okay, so we're going to do 6, 7, and 8 here since they're all kind of linked together. So for exercise 6, we want to make a list of the letters of the alphabet riffled with random reals between 0 and 1. So first couple of elements would look like A, and then a random real number, and then B, and then another random real number. So in order to get both of those things, we know that alphabet gives us our alphabet, and random real is going to give us a number between 0 and 1. If we want to riffle between those two things, then we know that we have our alphabet is 26 letters. So what we're going to want to do is make 26 random reals. So now we have 26 random reals and we have our alphabet. And so let's riffle them together. So riffle, alphabet, and our random reals. And now we have A, random reel, B, random reel, C, random reel. Fantastic. So our next thing in exercise 7 that we want to do is manipulate our alphabet and random real list so that we have loads of lists with a letter and a number. So the first few elements would look like this. So we'd end up with these things. So if we look at this list, all we really need to do for that is partition our list so that we have 2 elements in each list. So let's grab this line of code. And all we need to do is do partition of this into 2. And so now we have split our lists, partitioned our list into sections of length 2. Great. So let's actually do something with those letters and numbers. So we're going to use the numbers to style the letters with the hue of that number. So let's just remind ourselves what hue does. So if we have 0.2, it's going to give us this. And let's also remind ourselves how to style a piece of text. So if we have hello, then I can give that a color, and it's going to color it like that, which is nice. So we can use our nice little style function. So this is how the style, this is the data that style needs. So it looks like we want to use table for this. So we're going to do a table, and we're going to do style of, for now, we'll just leave it. We want something and something else in there. And the data type that we're going to give it is this little list of stuff. So in a second, we'll put those in. So what we want is, if we look at this, we want to take the first thing and put it here. And we want to take the second thing and put it here. So let's call this pair. And what we want is the first one. It's the first element in the list. And the second element of the list. And so now what we'll do with table is, for each item in this list of lists, we're going to call it pair, and we're going to take the first one here, the second one here, and we're going to do table to it. Why doesn't it love me? Oh, because I didn't actually do that. So we want to do hue in here. Boom. Great. So now we have our nice little alphabet that has our random real hues. So that's pretty swell. I love it. Okay, fantastic. So we have reached the end of that little series right there. So the next thing that you can do is you can head over to the project page, which I stopped doing. So you can head over to the project, and you can have a look at that project to do that computational poetry, or you can wait for day 5 where we'll go through all of those projects.